speed and velocity are two similar concepts, and they are directly related to distance and displacement. You can see the two equations here. Speed is equal to distance divided by time. Speed is equal to distance divided by time. Velocity is equal to displacement divided by time. From these two equations, you can easily understand that distance is related to speed, or speed is related to distance, and the velocity is related to displacement. So therefore, I hope to discuss about distance and displacement also during this video. By looking at the equation, we can write a definition for speed. Speed is the distance traveled within a unit time. Distance traveled within a unit time. In that way, again you can write a definition for velocity also. So how are you going to write? Speed is the distance traveled within a unit time. Therefore, velocity is the displacement occurred within a unit time. Displacement occurred within a unit time. And there's another way of defining speed and velocity: rate of change of distance. Rate of change of distance, very easy to memorize. Speed is the rate of change of distance. In that way, what is velocity? Rate of change of displacement. Rate of change of displacement is known as the velocity. And after that, it is important to understand the units of speed and velocity also. Here are the units. Speed is equal to distance divided by time. Normally we use meters and kilometers to measure the distance, and seconds and hours to measure the time. Therefore, we can construct two units to measure the speed. What are the two units? Meters per second. Meters per second. Meters per second. Kilometers per hour. So we have two units to measure the speed: meters per second or kilometers per hour. In that way, again we can construct two units to measure the velocity also. It is same as the speed, so I am not going to describe. From this, what you can understand, the both units of measuring speed and velocity, they are same. The units of measuring speed, meters per second and kilometers per hour. For velocity also, meters per second and kilometers per hour. The international standard unit of measuring speed and velocity, that is meters per second. Here distance is a scalar quantity. So let's discuss about the distance and displacement, because these two directly related to the speed and velocity. Distance is directly related to the speed. Displacement is directly related to the velocity. So this object start its travel from here, point A, and travel 100 meters towards east and come to a point called B, and after that from point B move downward 50 meters towards south and comes to a point called C, and then 100 meters towards west and end its travel at point D. So this object start its travel from point A and end its travel at point D. So we are going to find the distance and the displacement. So when we are finding the distance, distance means the length of the path traveled by an object. So in order to find the distance, you have to find the length of the path. Starting from here, you have to measure the length of the path, 100 meters, and again another 50 meters towards this side. So 100 plus 50, and another 100 meters towards this side. So therefore 100, 50 plus 100. Altogether the displacement become 250 meters. So this object travel a distance of 250 meters. and after that you can find the displacement. To find the displacement means the shortest distance between any 2 points. So to find the displacement, the easiest way, first you have to find the starting point. So A is the starting point. Then you have to find the end point. D is the end point. Then draw a line in between the starting point and the end point. The length of that line gives you the displacement. So the length of this line must be 50 meters. Therefore the displacement becomes 50. But displacement is a vector quantity with a direction. So displacement have a direction from starting point to end point, and so that's why 50 meters towards south. So 50 is the magnitude, south is the direction. Therefore displacement have both magnitude and a direction. Therefore we consider it as a vector quantity. Here distance, it's not a vector quantity, it's a scalar quantity, because it have only a magnitude. This number, that is the magnitude, and there's no direction. Therefore we consider it as a scalar quantity. So here's another example or a calculation related to speed and velocity. This particular student start its travel from point A and goes to point B 4 meters and again 3 meters and goes to the point C. So the starting point A, end point C. So first we are going to find the speed. To find the speed, you should find the distance. Here's the distance, length of the path traveled by the object, 4 meter plus 3 meter, altogether it is 7 meters. And after that, the time taken for this particular travel, you should consider it as 10 seconds. So you have to divide 7 meters by 10 seconds. So the answer becomes 0.7 meters per second. Meters per second is the unit of measuring speed. And after that, you have to find the velocity. To find the velocity, you have to divide displacement by time. So as I explained previously, how you're going to find the velocity, first you have to find the starting point, then the end point, and draw a line in between the starting point and the end point. Here's the starting point A, here's the end point C. Draw a line in between the starting point and the end point. The length of that line gives you the displacement. Therefore the displacement becomes 5. If the displacement becomes 5, time 10 seconds, 5 divided by 10, what is the answer? 0.5 meters per second. And it is important to mention the direction when you are telling about velocity. That's all. Thank you for watching.